Yeah, good evening all. I am going to explain the most important 2 or 3 marks questions. 2 or 3 marks questions in integration term 2 syllabus. In the previous class I have done almost 2 marks questions I covered. Here also 2 or 3 marks questions I am going to cover. And there are 15 to 20 questions. And there are 15 to 20 questions I am going to cover now. Just you can observe that. So integration 2 or 3 marks questions. This is related to term 2 syllabus. Right. Yeah, good evening all. So then I will continue now. Just now, because the previous class I have done 2 marks questions, the most important models. I am going to continue few more questions or 2 or 3 marks they may ask in term 2. Think now. See the first problem, integral x power 4 log x dx. Integral x power 4 log x dx. Whenever integral x power 4 log x dx, they may ask us 2 or 3 marks. Now see that when they are taken x power 4 log x dx, here I should use it first function, second function. If you remember ILATE, as per ILATE, here this is a logarithm and algebra, first function and second function. Generally if you write first into second, you will write first into integral second function minus derivative of first integral of second whole integral. If you follow this, I can write this one log x into, I can write log x into integral x power 4 dx, integral x power 4 dx minus integral derivative of log x, d by dx of log x integral x power 4 dx whole dx. I can consider like this. Now this will become log x power 5 by 5 minus derivative of log x 1 by x. This will be x power 5 by 5 dx. Now you can see here when I am doing this one, I can continue here. This will become x power 5 by 5 log x minus this again x power 4 minus 1 by 5 integral x power 4 dx. So this will be x power 5 by 5 log x minus, I can write 1 by 5 into integral of x power 4, again you will get x power 5 by 5, it will come plus c. So you will get, I can take it x power 5 by 5 common, I can consider, or I can simplify this. You will get x power 5 by 5 into, you will get log x minus 1 by 5 plus c. Like this we can write this. So that will be the answer here. Yeah, just you can go through that answer, you can verify that. So that way you can do this problem. X power 5 into log x minus 1 by 5 plus c. Right. Now here the next problem. I am going to the next one. So when they are talking the most important, at least one question they may ask. Remember the formula into e power x into f of x plus f dash of x. If it is like this, the derivative of f of x, f dash of x, your answer is e power x into f of x, which is equal to e power x into f of x plus c. So this concept is important. Sometimes the question they may ask using this concept. So here I can also write, for example, I can write e power x into x, they given e power x into 1 plus x dx. You can see here, this is compared with this, derivative of x is 1. So this is f of x, this will be f dash of x. Correct. If we compare with this, our answer is e power x into x or x into e power x plus c. Since derivative of x is 1, derivative of x is 1, you will get x into e power x plus c. For example, they may give the problem using this concept. They may ask integral e power x, I can write e power x into sin x plus cos x. Sin x plus derivative of sin x is cos x. So your answer is, I can write e power x into sin x plus c. I can write product of these two, I can write. Suppose like this, the models are important here. This is the basic questions here. But using this, they may ask like this. For example, they are given e power x, they can write e power x into 1 minus cot x, 1 minus cot x plus cosecant square x dx. Cosecant square dx. You can see this one. Suppose the problem is like this. You can see here the derivative of constant is 0. Here they may give these three terms as g. They may combine different way, because they can rearrange. But you observe here the derivative of 1 minus cot x will be cosecant square x. So d by dx of 1 minus cot x. We think of derivative of 1 minus cot x, it will be cosecant square x. So derivative of this is here. Then your answer will be, you can see, derivative of this function is here. So this will be f of x and this is f dash of x. So your answer is x e power x into f of x. So your answer here e power x into 1 minus cot x plus c. E power x 1 minus cot x plus c. You can express like this. Right. I hope you understood this right. That is, you can express that way. You can write the answer here. Right now. See the next one. I'm going to explain the next problem now. When I've written the next one, I think e power x 1 minus cot x plus c is clear. Now is the same concept. They can also ask here integral x into e power x by 1 plus x whole square dx. X in e power 1 plus x whole square dx. See, when they are asking this problem, x into e power x by 1 plus x whole square dx. Using the same concept, they are applying the concept is same. When they are using the same concept, you see that problem how they are writing this one. This is most important one. Whenever e power x is there, try to express here. You can write e power x into f of x plus f dash of x combination. You should work out. Right. If you work out this combination, I can write this one. I can write. So to get this one, so I can write this x. I can write 1 plus x minus x. I can write. So 1 plus x minus 1 by 1 plus x whole square into e power x dx. E power x dx. So I have written like this. Right. 1 plus x as, because add 1 subtract 1. Because I want in this form f of x plus f dash of x. So this one can I write 1 plus x by 1 plus x, 1 plus x by 1 plus x whole square minus 1 by 1 plus x whole square I can write into e power x dx. You observe here, I can eliminate this one with this square. So we have this one integral, I can write this one 1 by 1 plus x minus 1 by 1 plus x whole square into e power x dx. Right? The derivative you can see now, derivative of this one is this here. You can observe here, I can write your answer here. E power x into 1 by 1 plus x plus c. The reason d by dx of 1 by 1 plus x equal to minus 1 by 1 plus x whole square. Due to this we can write this. This model is also important. They may ask 2 or 3 marks. They can ask this problem 2 or 3 marks. Now you can see now another problem. Integral, same concept of this concept is most important. So suppose sometime they will give problem here like in a different way. They may ask the same model, they may ask in different way. So what is the different way means, they can ask suppose integral, they can ask x minus 3 into e power x, x minus 3 e power x by x minus 1 whole cube, x minus 1 whole cube dx. You observe this problem. When they are asking this problem, x minus 3 e power x by x minus 1 whole cube dx. When they are given this problem, just you observe here. how to simplify this. Always try to get the denominator x minus 1, you should get the numerator. So that I can write x minus 1, so minus 2 by x minus 1 whole cube, I can write into e power x dx. But whenever e power x, ultimately you should write f of x plus f dash of x. Now you can split this, I can write this one. So that easily I can write here x minus 1 by x minus 1 whole cube minus 2 by x minus 1 whole cube into e power x dx. Correct? I can express like this. So there are possible problems I am going to explain here. Now this one, this x minus 1 I can eliminate here with a 3, it will be 2. So you will get 1 by x minus 1 whole square minus 2 by x minus 1 whole cube. So you will get here e power x dx. Now you can check derivative of 1 by x minus 1 because you verify here d by d, suppose f of x equal to 1 by x minus 1 whole square. What is f dash of x? If you find f dash of x, it comes minus 2 by x minus 1 whole cube. How? 1 by x square minus 2 by x cube into derivative of x minus 1 is 1 only. So we will get like this. So the derivative f of x, f dash of x. So the derivative of this function is here. So your answer is e power x into f of x. What is f of x? By x minus 1 whole square plus c. I can express like this. These are important model like this. You can also try to practice these questions. Definitely you can answer this type of questions. Now one more question using the concept of like definite integrals. See this problem also, because I am covering the same model here. Suppose the example, the problem is integral 1 to 2. Suppose if they give integral 1 to 2, they will give 1 by x minus 1 by 2x square to 1 by, like this is x only here, 1 by x minus 2x square into, they can consider e power 2x dx. This is e power 2x dx. But always in the formula, you may think about e power x, but this is 2x. Then they are given 2x here. To get it here, the variable should be either x, one variable, single variable. So what I will do now, consider here, I can take the substitution here, 2x is equal to t. Take the substitution 2x is equal to t. The derivative of this, 2 dx is equal to dt. Dx is equal to of dt. When I transform it into t, then the limits also should change. These are the limits of x. So I can write when x is equal to 1, t is equal to 2. When x is equal to 2, t equal to 4. The limits will become t equal to 4. Then automatically this problem will become integral, see 2 to 4. I can write integral 2 to 4. Integral 2 to 4. Or I can write this is a 2x is equal to t. Correct. Now you can check that. I have written this is 1 by x. So t by 2 it will become, say because x by 1 by x means 2 by t minus, again this is a 1 by 2x square. So you get 2 here, I can write 2 into, this will be, I can write t square by 4. T square by 4, understood here. I am talking about 1 by 2x square, this one. You observe here, I can write the denominator. You write 2x square value. 2x square 2 into, you will get x square means t square by 4. So it comes t square by 2. This value will be t square by 2. It comes this one t square by 2. So 2x square t square by 2, it will come 2 by t square. Right. Because you have taken e power 2x will become e power, I have taken t e power t. Dx is off dt. I can write here dt I can write. Correct? We can express like this. It will come like this. 2 by t minus 2 by t square e power t dt. Now what I will do now, I can take it 2 common. 2 get cancelled with this. I can write 2 by 2 integral 2 to 4 1 by t. So this is 2 to 4 1 by t minus 1 by t square. This is e power t dt. Now check the derivative of 1 by t minus 1 by t square. Here I can eliminate dt, correct? Now you can check that d by dt of 1 by t. This will be minus 1 by t square. This we know that. So I can write now derivative of this one. I can write your answer is e power t by t limits 2 to 4. So you will get e power 4 by 4 minus e power 2 by 2. So this will be, if you want plus c, I can write. No, here not required. This is definite integral, plus c is not required. If you want, I can take it e square by 2 common. I can take it. I can take it e square by 2 common. Then you will get e square by 2 minus 1. E square by 2 minus 1. Or I can take it e square by 4 also common. So this is e square by 2 d square by 2. I can consider like this. You will get, this is one of the problem. So try to learn this combination of this formula e power x integral e power x f of x plus f dash of x dx. Try to learn that type of problems. Easily you can practice those problems. Next one. Suppose sometime they may ask the problem integral 0 to a 1 by 4 plus x square dx is equal to pi by 8. Pi by 8. Find a. What about a value? They may ask find a value. When they are asking a value, you have 0 to a. This direct question here, 1 by 4. I can write 0 to a 1 by. This is 2 square plus x square equal to pi by 8. But we know that 1 by a square plus x square dx is equal to 1 by a tan inverse of, always remember, 1 by a tan inverse of x by a plus c. This is the formula we have. This is x by a plus c. Use the same concept. We can use the same concept here because we have here pi by 8. This is pi by 8. If I apply the same concept, 1 by a, so 1 by 2 tan inverse of x by 2 because a is 2. This is 2 square. Tan inverse x by 2 limit 0 to a. I can apply which is equal to pi by 8. I can write this is equal to pi by 8. Now you can apply the limit here. This I can apply because they are asking to find a value. Find a value. Apply the limit here. I can take this one 1 by 2. Apply the upper limit tan inverse a by 2 minus lower limit 0 means this is because 0 to a. Lower limit tan inverse 0. 0 it will come pi by 8. So now I can eliminate to pi by 4. Tan inverse a by 2. So you can observe here tan inverse a by 2 equal, I got pi by 4. You can transfer 1 by 2 by 1 pi by 4. Then I can write a by 2 is equal to tan pi by 4. A by tan pi by 4 is 1. Clearly we know that tan pi by 4 is 1. So this will become a by 2 is equal to 1. Then a is equal to cross multiplication. This implies a is equal to 2 it comes. So this is the value of a. Answer a is equal to 2. Because tan 45 is 1. A is equal to 2. This is we can simplify like this. This is why I got a value here. I hope it's clear, right? Should I repeat any problem here? Please ask me. I can repeat the problem. If you are expecting to repeat, I can repeat the problem. So I think you hope you understood it's clear, right? Yeah, I hope it's clear. I can continue the next one. See that if I continue the next one now, the next problem. After this one, a by 2 is equal to 2. So the next one, I can write integral 1 to 4 mod x minus 5 mod x minus 5 dx. Suppose the problem is given like this, mod 1 to 4. Suppose between 1 and 4, this x minus 5 is negative. We know mod x definition. Mod x equal to x when x greater than or equal to 0, minus x when x less than 0. But between 1 and 4, x minus 5 gives negative. Correct, between 1 and 4. Because 1 less than x less than 4. In this case, mod x minus 5 will become minus of x minus 5. Because between 1 and 4, x minus 5 gives negative means minus of x minus 5. It will come minus of x minus 5. This will be minus of x minus 5. So I can write this one. So I can write this one 1 to 4. So 1 to 4 I can write minus of x minus 5 dx. Minus of x minus 5 dx. There you can do integration, your choice. You can do integration mod x minus 5 means directly We have many x minus 5 integral of x minus 5. Consider as one single term also, you can do that. Whole square by 2, like that also you can do that. Other if you do individual also, minus I can write x square by 2 minus 5x minus 5x. You can apply this 1 to 4. You apply the limit. Just you substitute the upper limit minus of, you will get 4 square 16 by 2 minus 20. And minus upper limit, lower limit 1 by 2 minus 5. You simplify this, minus 8 minus 20, you will get minus 12. 1 by 2 minus, you can see minus 1 by 2. This will be, I can write minus 1 by 2 plus 5. Plus 5 minus of this will be, you will get minus 12 plus 5 minus 7 minus 1 by 2. You will get 15, answer is 15 by 2. Your answer, right? You simplify, it goes 15 by 2. The answer is 15 by 2. Correct, we got 15 by 2. How about it's clear, right? I understood this, is clear? Should I repeat this? I hope it's clear, right? You can respond here in the chat box. Should I repeat means I can repeat. I hope it's clear. Alright. Another most important problem, another one I'm going to explain. After this, just go through this also. This was most important one. See many people they made a mistake in this problem. Integral, think about this problem. Integral 0 to 3 by 2. Integral 0 to 3 by 2. Step of x square dx. So this is step function or greatest integer function. Inside is x square. I given x square. This is step function. Or I can say greatest integer function. Step function I can say greatest integer function. Greatest integer function. Both are same. Greatest integer function. So whenever like the 0 to 3 by 2, the output gives only integers. Step of x square, step function is only integers. Between 0 to 3 by 2 means they are thinking about, you can think about the value, how to split this. So when you are talking between 0 to 3 by 2, I can split this value 0 to 1. Again I can write root to 2. Because the root to 2 whole square is 2 only. But this 3.2 is the root 2 value 1.414. Root 2 is 1.414. And up to they are talking about 3 by 2. 3 by 2 is 1.1. This is 3 by 2. So this is 1.414 and this is 1.5. Under root 2 comes left of 3 by 2. So because when you are taking x square will become 2. So integer it comes here. So that's the reason I should split like this. 0 to 1, 1 to root 2, root 2 3 by 2. Suppose you can see between 0 to the function I should split this. I can write between 0 to 1, if you take any number, square it, the step function gives between 0 and 1 only, here it gives 0. Between 1 to root 2, you square it, any number between 1 and root 2 square it. Again, the integer part will be 1 only. Between 1.414 into 1.5. If we consider this one, you see if we consider here, square it, the number comes 2. After that if you do any number between root 2 and 3 by 2, if you square it, you will get 2 point something, it comes 2. So that means I can split this problem, integral 0 to 1, step of x square dx, step of x, this is important, right, to understand here, step of x square dx, I can write again 1 to root 2, step of x square dx plus root 2, 3 by 2, step of x square dx. So this is the important concept to understand this one, x square dx. So when I have taken this one, you can observe here this one, which is equal to, here I wrote 0 to 1, like this value will be 0 to 1, 0 only, it comes 0 dx, I can see it will be 0. Between 1 to root 2, so it will become step of x square is 1 dx. Between root 2 to 3 by 2, so this will become only 2 dx. 2 dx. Now you can check the value, this will be 0. This integral 1 dx is x, limits 1 to root 2, and 2 dx means 2x, limits root 2 to 3 by 2. Root 2 to 3 by 2. Just if we substitute the values here, root 2 3 by 2, I can write this upper limit, lower root 2 minus 1 plus this one, 2 into, if we substitute this root 2, I have taken 2 outside, root 2 minus, I can write this one, x means, sir, upper limit I should substitute, right? Here I should write upper limit, you will get 3 by 2, I can write 3 by 2, and minus, I can write root 2. So this will become root 2 minus 1, it will be 3, and minus 2 root 2. Minus 2 root 2. You can check this root 2 minus 2 root 2, minus 1 plus 3, it comes 2, again minus 2 minus root 2, your answer will comes. Because 2 root 2 minus 2 root 2 will be, it comes only minus root 2, answer is 2 minus root 2. We can write 2 minus root 2. Correct? That will be easy problem. Go through this. This is important model. Just go through this step function. You should learn how to split this. Then after that, you can write. Then you try to learn this model is important. Alright. Now, because that model is important, they may ask that model. I hope it's clear, right? That model is clear, right? Understood that model. I hope it's clear. Now, I will do the next problem. So, when I am going next one, see the next problem. When I am doing next problem, integral minus 2 to 2, integral minus 2 to 2, I can write this is x cube plus 1 dx. X cube plus 1 dx. Whenever you think, whenever minus a to a, remember f of x dx. If f of x is, which is equal to 2 into 0 to a, f of x dx, when f of x is even function, equal to 0 when f of x is odd function, correct? F of x is an odd function. If f of x is even function, this one comes. This is even case. When its function is odd, f of x is odd function, then I can consider when the function is odd, the result will be 0. Correct? You remember this. But you come to here, x cube plus 1. Sir, how to decide even and odd function? You know that to decide odd function, the property is f of minus x equal to minus f of x. To decide even function, you know that what about to decide even function? Even means you can represent f of minus x equal to f of x. Correct? F of minus x equal to f of x. Coming to this, x cube plus 1. So can I do like this integral minus 2 to 2 x cube dx plus minus 2 to 1 dx. See what is x cube? Look into this data. Because odd means this is odd. In the case of odd, you can think in the case of odd, this is odd, right? So you take x cube, consider f of x equal to x cube. You take f of minus x, it will be minus x cube. So minus f of x, the function is odd. Because this function is odd function. F of x cube is equal to this function is odd function. Since the function is odd function, so this will be 0. Plus integral 1 dx, this will be x, limits minus 2 to 2. Correct? You can apply the limits now. If you apply the limits, then it comes upper limit minus lower limit, 2 minus of minus 2 plus 2, it gives 4. The answer is 4. That will be 4. Answer is 4. You got answer is 4. I hope it's clear. I hope, should I repeat this? Understood? Is it clear? Yeah. The same problem. Yeah. Yes, Aditya. Which one should I explain? Which problem? Is it what I explained now or the previous one? About even or Aditya, can I explain about even or odd function? You are asking about even or odd function? Yeah, please respond. Are you asking about even or odd function? Or the previous problem? Step function problem. Aditya, please respond. Do you want step function problem? The last one, what I explained now. That means even or odd function? Is it even or odd function? Yeah, x square. That okay. That I will explain. Okay, fine. Step function. Okay. Step function. Yeah, I will explain that. Yeah, fine. So can I understood? I can explain that. I will explain that. No issue. I will explain that. Okay. See that? Yeah, this is we completed. Now just I will go 1 minute to go. I will go back this one. Step function. See the step function. The concept is step of x square dx. When I take 0 to 3 but step of x square dx. Integer. You know that step of 1.2 it gives 1 only. Step of 2.4 it gives 2 only. Between it gives only integer part. So this is function. They given x square value. You take values 0, 1, root 2, 3. Why I have taken like this? If you square it between 0 and 1, any number if you square it, it comes 0 point something. Between 1 and root 2, you square it any number, it comes 1 point something only. Take any number. But if you take after 1.4, after 1 point, exactly you take 1.4. What is 1.4 square into 1.4? 2 point something it comes. Before root 2, the integer part will be 1. Exactly from root 2 onwards, the integer part of x square will become 2. X will become 2. So as for this, because x square value gives integer at root 2. Root 2 left of 3 by root 2 1.14, 1.414, 3 by 2 1.5. So here when you are taking x square, so this value here it will become 2 point something. So that's the reason you should split it root 2. So you should split it root 2, then I should continue like this. So as for 0 to 1, 1 to root 2, root 2 to 3 by 2, then you should continue. As for this I should write this. After you understood the procedure, how to do that. I hope is clear. Should I repeat again? Is clear? Aditya understood that? Should I repeat? Is clear? Then fine. Next, see the next problem. I'm going to explain other problems now. Integral, see that. Integral, this is also most important one. 0 to 1. Tan inverse of 2x minus 1. Tan inverse of 2x minus 1 by 1 plus x minus x square dx. Tan inverse of 2x minus 1 by 1 plus x minus x square dx. So this is the given problem 0 to 1. So this model is important. So I can rearrange this one. 2x minus 1 by 1 plus x minus x square. I can rearrange this one. How, sir? You can see this one. This x minus x square, you think x into 1 minus x. Correct. You take x common, x into 1 minus x. You will get like this. Right. Or if you take x square common, this x into, you will get x minus x square, it comes. I have written like this, right? What about this one? This one can I write? 2x minus, difference of this can I write? X minus of 1 minus x can I write? Check that. This is, I have written x minus x, x into 1 minus x. I have written this one x into 1 minus x. So difference of these two gives 2x minus 1. That means I can write this one 0 to 1 tan inverse of, I can write x minus 1 minus x. Because this is it. I can write x minus 1 minus x 1 plus x into 1 minus x. It is tan inverse x minus y by 1 plus xy form. Correct. You know that tan inverse. So this is tan inverse x minus 1 plus xy form. So I can write 0 to 1 tan inverse x minus tan inverse of 1 minus x. It will come like this. I hope it's clear, right? Because this is understood here. You remember the formula tan inverse x minus tan inverse of x minus y by 1 plus xy. If you remember this, tan inverse of x minus y by 1 plus xy means I can write tan inverse x minus tan inverse y I can write. Tan inverse x minus tan inverse y. So using this I have written like this. Then to simplify, very simple technique I can use here. Let it be this is I. You can let I is equal, I can continue this is I is equal to. They are asking the let it be I here. Because we know one of the property here. You remember the property here, integral 0 to a f of x dx equal to 0 to a f of a minus x dx. This is a property we have, a minus x dx. A minus x dx. So if we use this property here, this will become 0 to 1 tan inverse of 1 minus, replace x with 1 minus x minus tan inverse of replace x with 1 minus x, it will become x. In the place of x, 1 minus x, it will become tan inverse x dx. So this also y, correct, this also y. So let it be, this is function 1, this is 2. Now we are adding 1 into 2, we can add 1 plus 2. If we add 1 plus 2, these 2, if we add this 1, you will get I plus I integral 0 to 1. You observe here, if you add this 1, tan inverse x, adding this 1, minus tan inverse of 1 minus x, plus tan inverse of 1 minus x, minus tan inverse x dx. Correct. Now you can observe this one. I can eliminate this. Everything will be 0. 2y is equal to 0. Then I is equal to 0. The result is 0. I is equal to 0. I have taken this, apply the formula, then you can get I plus 1 plus 2. I plus 2i equal to 0, I equal to 0. The result will be 0 here, I equal to 0. Right, you got that I equal to 0. I hope you understood this. Next, another one. I can discuss another problem now. Right, integral x cube by root of 1 plus x square dx. Integral x cube by integral x cube by root of 1 plus x square dx. So this is a problem. This model is important. When they are given like this, I can consider here 1 plus x square is equal to t square. I can eliminate root. Then you will get derivative differentiating with respect to dx. You will get 2x dx is equal to 2t dt. And x dx is equal to, I can write t dt. Because x square I can write x dx. From this this is x cube, I can write x into x square into x by root of 1 plus x square dx. Root of 1 plus x square dx. Correct. Now, when I have taken like this, now you can observe here. This one I can write x dx. This x dx I can eliminate as t dt. Correct. T dt. X square means t square minus 1. That we can eliminate here. So I will write this is t dt. That means if I write what is x square, t square minus 1, t square minus 1, this is t dt by root of this 1 plus x square is t square. So this will become t square minus 1 into t dt by, it comes t. Then you observe here, this t and this I can eliminate. Now if you do integration this one, it will come now, I can write t square t cube by 3 minus t plus c. It comes like this, right? This will be easy here. But we know t square is 1 plus x square. T means root of 1 plus x square. T cube by 3 we got. We got t cube by 3. So I can write the value 1 by 3. We know 1 plus x square is equal to t square. So here what I can write here? I can write 1 by 3. 1 by 3. T cube means t means root of 1 plus x square. I can write 1 plus x square whole, that means 1 plus x square whole power 3 by 2. minus you will get t means root of 1 plus x square, root r 1 plus x square, root of 1 plus x square plus constant. We get like this. This model is important. Take 1 plus x over t square, you differentiate this x raised to t dt, then you write x cube x square into x, then you write x square plus t square minus 1, x dx t dt by root of t square, you simplify, then you will get this is required answer. Should be careful if you resubstitute, if you replace t with root of 1 plus x square, you should be careful. This is 1 by 3. 1 by 3. Next one. Next one, the most important one. Next one, the problem. Integral. The most important one I am going to explain. This is the most important one. You can think about integral 0 to pi by 2. Integral 0 to, they talk about integral 0 to pi by 2. Pi by 2 root of 1 minus sine 2x dx. In the previous class also I have discussed about this model. You remember 1 minus sine 2x, always it can be expressed as cos x minus sine x whole square. Why is outside? Write 1 cos square x plus sine square x, sine 2x, 2 sine x cos x minus sine x whole square, or sine x minus cos x you can write. Preferably you write cos x minus sine x whole square. But when you have taken this one, integral 0 to pi by 2, it comes root of, it comes cos x minus sin x whole square. I have taken this. Then the important point is it comes mod here. When I have taken, it will always remember when they are talking about this one, root x square is mod x. Same concept becomes 0 to pi by 2, it will come mod cos x minus sin x. Most people, they will forget about mod value, mod cos x. Simply they may write cos x minus sin x. You should be careful. So because 0 to pi by 2, when they are talking between 0 to pi by 2, so this is pi by 4. 0 to pi by 4, pi by 4 to pi by 2. So this area will be different, this area. See in this area always cos x minus sin x is, here it goes positive. Cos x minus sin x is positive, it comes here. Cos x minus negative in this area. So you know definition of mod x equal to x when x greater than 0 equal to minus x when x less than 0. Remember definition of mod x. Definition of mod x equal to x when x greater than 0. When I am talking about this is x greater than 0 equal to minus x when x less than 0 and 0 when x equal to 0. But here if you take difference of this is positive here and negative here, so I can split this. So this is the most important concept. I can split this function 0 to pi by 4 mod cos x minus sin x dx. I can write pi by 4 to pi by 2 mod cos x minus sin x dx. You should split this. This is sin x mod cos x minus sin x mod cos x minus sin x dx. Now when I have written like this, you observe here, when I have written there like this, in this side of 0 to pi, this is positive, so I can write 0 to pi by 4, directly I can write function cos x minus sin x. I can consider this. But here the difference is negative here, so minus of it comes, I can write minus I can write out minus of pi by 4 to pi by 2, it will come cos x minus sin x. Cos x minus sin x. It comes like this. Now I can substitute the limits. If I substitute the limits, integral, I can substitute the limits now. Integral cos x, it will get sin x. We know that. In minus sin x, integral sin x is minus cos x minus plus cos x. Sin x plus cos x, limits 0 to pi by 4 minus of cos x. Integral cos x is sin x, it comes sin x. My integral this one, I have written minus, I have written here, right? So cos x minus integral cos x is sin x and this will be cos x. Limits will be, you will get pi by 4 to pi by 2. Pi by 4 to pi by 2. Right, pi by 4 to pi by 2. Well, minus it will come outside, right? Now you simplify. This will be sin pi by 4 plus cos pi by 4. Substitute this sin pi by 4 plus cos pi by 4 upper limit. Substitute cos pi by upper limit minus lower limit sin 0 plus cos 0. This is over. Correct. And minus this one. Same thing. This is minus sin pi by 2. Sin pi by 2 plus cos pi by 4. Cos pi by 4 minus, I can write sin pi by 4 plus cos pi by 4. Cos pi by 4. You substitute the values. This one minus of this, I can write minus of this inside the bracket, right? You should be careful here. The simplification should be careful. I can write like this, right? Upper limit minus lower limit. If we substitute the value here, this one, sin 45, 1 by root 2, cos 45, 1 by root 2. 1 by root 2 plus 1 by root 2, 2 by root 2. Correct, this will be 1 by root 2 plus 1, we will get 2 by root 2, root 2 it comes. Minus sin 0, 0, cos 0 is 1, root 2 minus 1, this part. The sin pi by 2, 1 it comes, sin pi by 2, 1. Cos pi by 4, 1, it will get 1 by root 2. 1 by root 2 because inside this 1 by root 2 and minus sin pi by 4 you'll get 1 minus 1 by root 2 and minus cos pi by 4. So I think I can simplify this minus 1 by root 2. You'll get like this. I expand minus 1 by root 2. So I can eliminate this one here. Minus 1 by, I can eliminate this. Now you can simplify. It comes answer here root 2 minus 1. It comes minus 1 minus 1 minus minus plus 1 by root 2. It will come this, right? So this is a value it comes. You can check this one. If you simplify this one, the answer it comes, you can verify here. We should be careful the simplification. Always you should be careful when you are doing the simplification. That is the most important. When you are doing simplification is most important. Minus of this I have taken this one. Sin pi by 2. Pi by 4 cos pi by 4. Correct, when I simplify 1 by root 2. This it will come. Root 2 minus 1 by root 2. This is minus 2. Root 2 minus 2 plus 1 by root 2. You can check this one. It will come root into 2 minus 2 plus you will get 1 by root 2. The value it comes. So verify the value, everything I read it. Verify this value sin 45. This will be 1 by 2 by root 2, root 2 only. Sin 0, 0 written minus 1. Be careful here applying the limits. Pi by 4 to pi by 2. Pi by 2. Sin pi by 2 plus cos. I have written this one. See here. See the mistake here. Sin pi by 2 cos pi by 2 I should write here. See, you should be careful here. Where this is sin pi by 2 cos pi by 2. I have changed it now. Cos pi by 2 minus sin pi by 4 cos pi by 4. You should be careful. So then I will change the answer. Now you can see here. You should be careful with the substitution. By mistake you may write, I have written here pi by 4. So if you do like this, the changes just 1 minute. I will complete with this problem. Root 2 minus 1. I have taken this is root 2 minus 1. This part is root 2 minus 1. Minus of sin pi by 2 1. Cos pi by 2 0. This is 1 plus 0. It comes. Minus again sin pi by 4 cos pi by 4. 1 by root 2, 1 by root 2 by root 2. It will be root 2 it comes. So they now answer root 2 minus 1. It will be minus 1 plus it comes root 2. So this will be 2 root 2 minus 2. Answer is 2 into root 2 minus 1. We should be careful. Before I have done mistake, I have rectified that. 2 into root 2 minus 1. That will be our answer. 2 into root 2 minus 1. Is clear? I hope you understood this. Should I explain again? This is it clear? What I explained just now. I understood that. Is it clear that problem? The model is most important model. Should not miss that. The model is most important. Yeah. My dear students, is it clear? Dears, is it clear about just what I explained? I understood that. Right? Yes. It's clear. Should I repeat the problem? Means I will repeat. Should I repeat the problem? Okay, like 2 or 3 marks questions, this is one of the part. Maximum tomorrow I can complete this topic. This topic will be completed tomorrow. Tomorrow I will discuss few more questions, 2 or 3 marks questions, most important questions. Definitely we can expect the questions in term 2, no doubt in that. I will cover few more questions the next class. The next class Monday I will cover. Monday evening same 8:30 to 9:15 or 9:20. I will cover few more extra questions. After that, if completes, then I can do the long answer questions also, 4 marks questions also. So definitely I will complete the coming week, like all the topics I will complete, or like all the days. Like every day if I concentrate 45 minutes, I can complete the revision for all the topics. Then thank you. Good night. See you in the next class. If you like the session, or you can write, you can express your comments also. Please express your comments also in the comment box. Tell me your comments in the comment box. Yeah, write your comment box or liking. Please encourage me, I can do more. Like, and even comment box also you can express your wish. Yeah, I hope you understood. I've tried my level best. Still I can explain most important questions. I will do that. Fine then.